Assalamualaikum and very good day. Yeah, now we want to discuss about the Albert Batch formulation. And so the objective of the Albert Batch formulation, is we want to derive uh, wind power generation. Yeah, before we have discussed about the wind power generation, is given by 1 over 2 rho A V power 3. Now, the Albert-Batch formulation, has derived that the wind power, yeah, is contained wind power, what we can call the power of wind turbine, that given by the 1 over 2 rho A V power 3, and one coefficient factor, yeah. Now, meaning the difference between wind power that derived by the Albert formulation and also general wind power is different only in the coefficient power, CV. Now, so it is illustrated by this figure. Look at this wind power generation. The type of the horizontal axis wind turbine. Yeah, the condition of the wind speed can be divided by three parts. The first, wind speed in front of the wind turbine, that we can call upstream wind speed, V0. And then this V0 goes or flows, through the A and arrive the wind turbine. This one we can call, is upwind speed, V1. V1. After striking this wind turbine, the wind, arrive behind of the wind turbine. The wind speed we can call the downwind speed. Downwind speed. So starting from the V0, V1, V2 here, the area of the wind speed, forms a steam tube. The steam tube like this one lah. It is V0 area, and then after arriving on the space of the wind turbine, the area is A1. Cross section area in the A1 on the wind turbine. After striking, area like this one. When the wind speed for the V2 downwind speed. Starting the wind speed, in front of the wind turbine V0, and then V1, and then V2, or the movement of the wind, has the ms, m dot here, means ms flowing through the turbine. It is given by m dot is equal to rho a1 v1. Rho a1 v1 means, when the ms in the space of the wind turbine with the cross section area of the wind turbine A1 and wind speed arriving the wind turbine, is V1. So mass air mass or m dot is given by rho A1 V1. Okay, and then the wind speed the wind moves, starting from the A0 area A1 until A2. The movement has force. The force of the wind speed, starting V0 until V2, is given by F is equal to mv0 minus m dot v1. It is a rate of the change of momentum from the ms flow rate. This one. Now, so from here we can see that v0, v0, is equal, v0 is higher than the upstream wind speed. And then when the wind speed arriving the wind turbine, now so the wind turbine move. The movement wind turbine indicates that the wind turbine has power extracted. Power extracted. It is multiplication of the force and speed, wind speed on the wind turbine V1. Now, so Vx is given by F V1. F was multiplication of wind speed on the wind turbine V1. So we can write m dot multiply m0 minus V2 multiply V1. Okay, and then before we have explained that the power is given by the when we have the ms power related to the here uh, wind speed. Now, so power related to kinetic energy is given by 1 over 2 m dot multiply v0 minus v2 power 2. 1 over 2 m dot multiply v0 power 2 minus v2 power 2. Okay. So from here, we have two types of the power. The first is power extracted on the wind turbine, and the second movement has the kinetic energy power causes by the energy kinetic. So we can write that the px is equal to p. So m dot multiply v0 minus v2 equal 1 over 2 m dot multiply v0 power 2 minus v2 power 2. It is same. Okay, and then the value of v1, value of the wind speed on the wind turbine can be given by this one. V1 equal v0 plus v2 over 2. Means v1, if it is in front of the wind turbine, v0 arriving the wind turbine v1 after striking this wind turbine and goes to behind the wind turbine v2. So v1 here is equal to the summation of the v0 plus v2 over 2. Or from here we can write that value of upstream wind speed v2 is equal to 2 v1 minus v0. And then we have the ms is equal to rho a1 v1. If these two components we substitute to the power extracted by the wind turbine, we can write here m dot is substitute by here, and then v2 is substitute by here. So lastly we have obtained the value of power extracted that given by 2 rho a1 v1 power 2 multiply v0 minus v1. Okay, and then in this case we understand about the perturbation factor. Perturbation factor A. Yeah, this perturbation factor A, yeah, is defined as the friction decrease of wind speed at the wind turbine. And then the value of perturbation factor A is given by, yeah, wind speed in front of the wind turbine, yeah, minus wind speed on the wind turbine divided by wind speed in front of the wind turbine. Yeah, or we can write also V1 is equal to 1 minus A multiply V0. Yeah, this one. Okay, and then value of V1 here, we substitute to here. Yeah. Now, so we obtain the perturbation uh, factor A is given by A is equal to V0 minus V1 over 2 V0. Yeah, here. And then if we substitute value of V1 equal 1 minus A multiply V0, yeah, to the power extracted by the wind turbine that obtained from here. Yeah, V1 here is substitute by here. So lastly, we have the formulation this one. Vx is equal to 1 over 2 rho A1 V0 power 3 multiply VA multiply 1 minus A power 2. Yeah. Look at from this formulation, yeah, that we have two parts. The first part is 1 over 2 rho A 1 V0 power 3. Yeah, it is give symbol V0. And for the VA multiply 1 minus A power 2, it is CV. CV is power coefficient. Yeah. Now, so P0 is power of the turbine is given by this one. Yeah. 1 over 2 rho A1 V0 power 3 and power coefficient CV min equal 4A multiply 1 minus A power 2. What is meaning of this one? Yeah, means that the power extracted by the wind turbine, yeah, is considered by two parts. The first power of the wind turbine that given by the 1 over 2 rho A1 V0 power 3, yeah, it is the generation formulation of the wind power that we know, ya, selama ini. And the second is power coefficient, means the Albert, yeah, formulation consider the value of power coefficient to calculate to obtain the power extracted by the wind turbine. Yeah, only consider by the value of power coefficient that it is given by the Cp equal Va power multiply 1 minus A power 2. Yeah, this one. Okay, now so what's meaning? Meanings we want to obtain the maximum power extracted by the wind turbine by considering the value of the power coefficient CV. Yeah, CV. Where the coefficient CV is given by this one. VA for A multiply 1 minus A power 2. Or if we want to write it like this one, can V for A multiply, yeah, 1 power 2 minus 2A plus A power 2 can. Now, so we have the one formulation where the variable, yeah, is powered by 3. And then if we draw, yeah, if we draw the graph, yeah, if we draw the graph, we can obtain the graph like this one. The horizontal axis is perturbation factor A, yeah, where A in here is plot from the 0 to 1. And the vertical axis is power coefficient, Cp. Yeah. Now, from here, we obtain the maximum of the Cp, the point, let's say, in here. For this point, yeah, 0 point something for the vertical axis and the horizontal axis. How many for the perturbation A? Yeah. Now, so in here exactly we can look at this simulation lah. Yeah, the simulation for the power coefficient. Yeah, power coefficient because we want to know the value of the perturbation and the value of the power coefficient. Yeah, power coefficient. Now this one. Yeah, it is A. I plot here from the 0 to 1 by resolution 0.01. And then this one is formulation of power coefficient for multiply A multiply 1 minus A power 2. So we can see the graph. Okay, like this one. Yeah, same for this case. Yeah, for this case. So from here we can see, yeah, that from the code we want to find the maximum CP, yeah, power coefficient, the maximum CP. Using the result, we obtain 0.5925. Now, so we can see here, yeah, by using this one, okay, obtain the same, yeah, 0.5925 means the maximum power coefficient, yeah, of 0.5925 is obtained when the perturbation factor A is 0.33. Yeah, 0.33. This one means following this one that the power extracted by the rotor blade, yeah, by the wind turbine will be obtained when the perturbation A is 0.33. Yeah, this one. Or if we want to find by using the formulation here, yeah, please, because we want to obtain the maximum, yeah, maximum value. Now, so we can obtain the derivation of CV, yeah, to the A, yeah, is equal to 0. Yeah, please, when we derive, uh, when we give the derivation of the CP to A, we will obtain the value of perturbation A, yeah, two value. The other value will be obtained is A equal 0.33. Yeah, please try lah. We will obtain the value of A is 0.33 by using this formulation. Yeah, dCP over dA is equal to 0. Okay, and then the other terms when we discuss about the wind power generation is tip speed ratio, TSR. TSR is speed at the rotor tip divided by the wind speed. Now, so the formulation is given by this one. Rotor rip speed divided by wind speed equal RPM multiply Vd over 60V. Yeah, D in here is diameter of wind turbine. V is wind speed. Okay, now so in here, yeah, we can conclude that the if TSR is high, it means that the blade spin too fast, that the blade will experience turbulent winds. Yeah, yeah, we can see TSR. If the high, blade spins too fast. If the TSR low, mean the blade spin too slow. Okay, this one. Okay, now so the condition we can indicate by some graph here using the, for example, batch limit, ideal efficient, high space two blade, and then modern three blade, there is rotor, American multi blade. Horizontal axis is this tip speed ratio. Yeah, it is the tip speed ratio. If the high, yeah, spin, rotor blade spin to pass. Yeah. Now, so efficiency. How about the efficiency? Yeah, please look at some of the method here for the graph. Okay, look at the sample. A 40 meters, 3-blade wind turbine produces 600 kilowatt at a wind speed of 14 meters second. Air density is the standard 1.225 kg over meter power 2. At what RPM does the rotor turn when it operates with TSR of 4? Yeah, means here we want to find the RPM of the wind power generation. Yeah, for the blade diameter 40 meters, wind speed 14, and TSR 4. So by using this formulation, yeah, TSR equal RPM multiply pi multiply D over 60V. Yeah, from here we can write value of RPM is equal to TSR multiply 60 multiply V over pi multiply D. Yeah, please substitute value of V is 14, value of TSR is 4, value of diameter is 40. Yeah, from here. Now, so RPM is 26.75 RPM. Okay, thank you very much.